Okay, welcome back. So this is week 2.2 on psychological measurement. I have to say this is actually one of the most important lecture for you. Some of the concepts that you will be learning are really basic, really fundamental for you in answering your first assignment, right? So you really have to be clear on many of the concepts that I'm going to share with you about. Now, this course on this particular part of this lecture is on psychological measurement. Some of you would equate, all right, or as I have, with peering into the minds of another person. All right, very often, why why do you want to do psychology, right? One common response is you want to understand how people are thinking, what people are feeling, and so on and so forth, right? So it's as if you're peering into the minds of another person. Obviously, we know that we can't really do that, at least not like this, right? But we can do it with proper research methods, right? We can peer into other people's minds with the proper kinds of tools. We can measure what their thoughts are, what their feelings are, and so on and so forth, right? So this particular part of this lecture is dedicated to measurement issues. In JCU curriculum, there is another fourth year course. There's another third or fourth year, yeah, third year course, and I think the title of it is psychological assessment. Um, this is not quite when it comes to psychological measurement, it's not exactly the same as psychological assessment. So in terms of meaning of the word assessment and measurement, right, in English, they can be very similar. And even in terms of principles, right, the principles of psychological measurement can be very similar to the principles of what you want as psychological assessment. But for practical purposes, especially for this course, right, I'm going to make a big distinction between these two, even though they are somewhat related. Assessment usually has to do with clinical assessment. Uh, in a case that you're assessing whether this person is likely to reoffend, you're assessing this person's capability for probability of success in a rehab program. You're assessing whether this person has clinically problematic issues or not, right? This is what we would call psychological assessment. Obviously, Dr. Diff, she probably has a far greater nuanced understanding of what assessment is. So if you ever have a chance to talk to her about assessment, right, please do. I don't know too much about assessment as she does. When it comes to psychological measurement, we don't necessarily have to deal with clinical issues, right? We can measure self-esteem um, without thinking that self-esteem is something that low or high self-esteem is something clinically problematic. We can measure how happy people are or how sad people are. We can measure people's conformity, right? All these issues, happiness, sadness, conformity, self-esteem, right? They don't necessarily come into play in a clinical context. Maybe they do, right? But they by themselves, they are not necessarily clinical issues. Certainly not like rehab, recidivism, and other clinical issues, right? So there is a distinction between psychological measurement and psychological assessment. This is in the context of this course is usually non-clinical, and in this one in the context of JCU's curriculum is JCU's curriculum is usually clinical. Now let's get on to some basics. The fundamental logic of why you should think of assessments, all right, what fundamentally assessments are, is because a lot of psychological constructs that you actually want to measure, they are abstract concepts. Think about this, right? You have self-esteem. Can you see self-esteem, right? Self-esteem is not a label that you can stick on your skin and says, oh, I have 7.1 levels of self-esteem, right? That doesn't work this way. Think about conformity. right? There's no label on above your head that tells you the level of conformity that you are, or the level of extroversion, or the level of neuroticism, or the level of selfishness that you might have, right? So a lot of these psychological constructs that humans have, they are abstract concepts, right? Some people like to say that they are socially constructed, that there's some truth to that. But whether they are socially constructed or not, right, I think all of us have to agree that psychological constructs are abstract. Many of them are abstract. Now, in contrast, physical constructs like gravity, right? You know it exists. If you drop an apple, uh, above the ground, you know that it will land, right? So in some sense, gravity is a physical construct. Your height, your weight, the length of your hair, all these are physical constructs, right? I still need to measure them because I can't just look at you and tell you how heavy you are, or how tall you are, or how long your hair is, right? I still need to measure them, but they are, in a very broad sense, they are height, weight, length of hair. They are physical constructs, right? They are not abstract concepts, they are concrete concepts, right? Whereas psychological concepts are very much often abstract. Now, the problem with abstract concepts is this, right? In order to know that these constructs exist, right, you need to make them concrete, right? Because they don't show up just like that. They don't show up on your skin. They don't show up above your forehead, right? So in order to know that these constructs actually exist, you need to make them concrete, right? By making concepts, abstract concepts concrete, right? That is what we call measurement, right? So this is the fundamental logic of why you would do psychological measurements. Now, today, for this part of the class, we will learn about two issues, right? Reliability and validity. Next week, we will expand our understanding of these two into a technique called factor analysis. Right? Basically, is there an underlying factor regardless of all the measures that you are actually measuring, right? Again, if this doesn't make sense to you right now today, don't worry, right? It's something that will become clear as we go about next week. Beyond 3101, right, you can Google some of these advanced issues in psychometrics. I'm definitely not going to go through them, right? These are way beyond your level 3000 level, 3000 course. Now, what is psychometrics? Some of you might have heard of this term before. It sounds like a very fanciful term, but really it's a very, very simple term, right? It's just an area of psychology, a specialization in psychology that seeks to understand, how can things be best measured? What are the issues that we need to consider when we are measuring something? If everything was just as simple as take a ruler out and then measure, right? But we know that psychological constructs are not as easy to measure as we think it is, right? In the context of self-esteem, right, you might have a 7-point scale on self-esteem, right? You might want to ask your friend, right, how do you feel about yourself? But is that the correct way to measure self-esteem? Right, so many people, very often, right, sometimes we engage in conversations disagreeing about the nature of measurement. It's not that these constructs cannot be measured. It's that people have different ideas on how best to measure the particular constructs, and this is sometimes the expertise of a psychometrician. So, what is a measurement? All right. Technically, a measurement in the context of psychology, it's a quantifiable attribute. Quantifiable means that you can assign a number that says how much, for example, how much, how fast, how long, how many, and so on and so forth. Right? So it must result finally in a number. Now, this very much differs from qualitative data. In a qualitative data, right, let's say you want to understand, this person's level of self-esteem, you can certainly engage in a conversation, in a 2-minute conversation, in a 5-minute conversation, and from all that he said, right, you can gauge the level of self-esteem. Now, if all the data that is produced, that is coming in, is all text data, you still need to find some way to convert all this text data into a numerical judgment of how much, whether this person is high or low in self-esteem, right? So by converting text to numbers, right, you are engaging in, quantifying, right? You're making self-esteem a quantifiable attribute, right? By measuring a construct, you are also telling the reader or telling yourself what a construct is not. Okay, let me repeat this again. By claiming the existence of something, right, you are also claiming the existence of something that is not. If you say that this person has high self-esteem, right, you implicitly are creating what is known as self-esteem, and also demarcating this idea of self-esteem as different from, say, introversion, extroversion, neuroticism, and so on and so forth. Right, so that's the idea behind this point. Whenever you're measuring something, you are also at the same time measuring something that is not. Now, all this should look very, very familiar to all of you, right? Independent variables, dependent variables, predictor, criterion, continuous, discrete, qualitative, quantitative. Now, when it comes to measurement, right, it's very important to take into some of these properties of the measure that is supposedly captured. Once you measure something, you are immediately, almost certainly, turning it into a variable, right? A variable comes from the word variable comes from the word vary, right? So if you can measure something, probably not everyone scores the same way as you did, right? So there will be some variation, right? So that creates this thing called a variable. And a variable, every time you hear the word variable, right, all these terms should come into play, right? So you should be very familiar with your concepts, or these 8 concepts. You should just as well be very, very familiar with what is known as scales of measurement. Now, I probably don't need to go through with you what nominal scales, ordinal scales, interval scales, and ratio scales are. You really have to be very, very clear about what these things are, because when it comes to the most problems that I see actually comes in the parametric analysis, non-parametric analysis, which we will undergo, I think, 2 weeks from now. But you really need to be very careful about nominal scales, ordinal scales, interval scales, and ratio scales, right? So revise these concepts if you're not already very familiar with them. Okay. So most psychological constructs, I told you, are abstract. Some people would use the word latent variables as well. Very often we think of them very, very similarly. I mean, casually I would say them as abstract, but statistically you would call them as latent variables. Latent variables just means that they are present, but yet they are invisible. Like self-esteem, right? We kind of know that self-esteem exists. You and I have different levels of self-esteem, very likely, but they are kind of invisible until we make them into visible, measurable, and so-called visible, concrete constructs. Many other attributes also have, are many other psychological attributes are also abstract, right, and latent. For example, intelligence, which I kind of mentioned it already. Evilness, right? Let's say you want to say someone is a very evil person, right? So you're implicitly saying that by you saying that this person is an evil person, you have some intuitive idea of what evilness actually means. You have an intuitive idea of how to measure evilness, right? Good, whether you are measuring it good or not, right? That's the secondary question, but you do have some idea of what evilness is, right? Memory, right? Memory is also something that we can. It's kind of like an abstract concept, all right. But nevertheless, all of us know that we all each have our own memories, and because they are abstract concepts, their existence needs to be inferred. Now, the problem with inferring the existence of an abstract concept is this. How do you make strong inferences? Now, I'm going to show you a picture of a middle finger, right? Some of you will be very offended by if I actually do show you a middle finger in a real classroom. But take a look at this picture, right? Obama is showing a middle finger. Take a look at this picture. A baby is showing a middle finger. And take a look at Simon Cowell, right? He is also showing you a middle finger. Now, most of us would think that a middle finger, rightly or wrongly, right, is a very rude gesture, right? It has some sexual connotation. It stands for a particular word that is too vulgar to utter in a lecture, right? But these three, right, if you see them, right, do you think they are being rude? Many of us would probably say, yeah, if someone shows me a middle finger, right, they are, expressing their displeasure at me. But if these three people show me their middle finger in this context, right, we think of it as, just nothing much, right? It's not a rude gesture. So inferences, if you treat this concept of rudeness as an abstract concept, and if you infer rudeness from the presence of a middle finger shown to you, then obviously in this three context, your inferences would be wrong, right? So the key here is this, right? How do you make strong inferences from to infer the existence of an abstract concept, in this case, rudeness? Now, psychologists grapple with this kind of questions all the time because, well, like it or not, our constructs are usually abstract. So we have to take into consideration two things, right? One is the reliability and one is the validity when it comes to measuring things, right? Measuring psychological concepts. Reliability. Measurements are almost always imperfect, right? Even in natural sciences, even if you want to measure the length of a ruler, your weight, it's not going to be the most perfect measurement ever, right? Your weight might be 55, 51, 55.13, but your weight would change if you just had a meal. Your weight would technically change if you just emptied your bladder or emptied your stools, right? So even in physical constructs, right, measurements are always imperfect, let alone psychological constructs. So this point here, right, is true both of physical constructs and of psychological constructs. The fundamental principle is this, right? Now, assuming that something actually exists, assuming that this thing called self-esteem actually exists, or this thing called conformity actually exists, right? There is an observed score, which is, say you have a 5-item measurement of self-esteem or a 5-item measurement of conformity, right? Whatever, right? So there is an observed score and there is a true score, right? The true level of self-esteem, the true level of conformity, the true level of evilness, and so on and so forth. Ideally, your observed score would be your true score. In reality, your observed score is the true score plus some kind of error of measurement, right? There is always a tiny error. Well, it can be tiny, it can be large, but there's always some kind of error associated with your observed score. Right, so that's the tricky part of psychological measurement. How do we minimize this error of measurement? Theoretically, if the error of measurement is 0, right, then obviously observed scores equals true score. Now that we know that every measurement always has some error of measurement, right, the only thing that we can best do really is to reduce this error of measurement such that it becomes nearly 0 or as low as possible. How do we do that? First, we need to identify some sources of errors. Some errors are systematic, some errors are random. Now, take a weighing scale, for example. If you always weigh 5 kg more, right, you step on a weighing machine and you know your true weight. Let's say you by some miracle you actually do know your exact true score, right, without error. And you find that, this weighing machine that you just newly bought always gives you a weight of 5 kilograms more, right? That's not a problem because you can always subtract 5 kilograms from whatever readings that you actually have. Now the real problem is comes with random errors, right? Random errors are, well, like the word suggests, random. Let's say you have an inconsistency, and you always tend to misread the weight that is shown on your weighing scale, right? And you don't necessarily always misread it in one direction, right? Sometimes you are a little under, sometimes you are a little over, so there's a lot of random error. So obviously, if you can reduce random error, right, your measurement, your true measurement is going to be a lot more accurate. Systematic error is not so much of a big problem because you can always, if you know the systematic error that actually exists and you know the amount of systematic error that actually exists, you can always do a mathematical subtraction or mathematical addition, right? So systematic error can be corrected. Random errors can be cancelled out if you are taking a lot of measurements at the same time. Obviously, sometimes it does cost a lot to correct for systematic error. So typically we think that, oh yeah, technically systematic error is solvable, but it can come at a huge cost. This happened in France. A particular train that was newly manufactured for the French railway company was found to be, I think, 2 inches wider than it was supposed to be, right? 2 inches can be a lot, right? That means that a train would almost certainly crash into every platform if it were to operate. So obviously the natural decision, right, the natural thing to do is to shave off two you can shave off 2 inches off every train that you have bought. Let's say they come in 100 million, so right, you have to shave off all the trains, or you can shave off 2 inches off every platform in a country. In either case, right, you know that it's going to come at a cost. Random errors, in some sense, can be cancelled out. Let's say you want to find out your true weight, right? Let's say your true weight is 55, is 60, 70, doesn't really matter, right? And you know that you always make some kind of random errors. But if you take 30 measurements over 30 days, right, more or less you will converge on your true weight, right? So in some sense, random errors can be cancelled out the more number of measurements that you actually take. In some cognitive experiments, you might have undergone, there are multiple trials, right? And you might be wondering, right, why do I have to respond to multiple trials? Or for example, the Stroop task that many of you are familiar with, and it's usually taught in introduction to psychology, right? A Stroop task is where you respond to color of words based on color of stimulus, right? So why don't you just have 4 trials for a Stroop task, right? Often you have 20 trials, 40 trials, 80 trials, right, in order to get what is known as a Stroop effect. Technically, you can just have 4 trials, right? The reason why we have that many trials, 20, 40, 80, 160 trials, is because we assume that every measurement of reaction time does have some kind of random error. But we assume that with more measurements that is taken, right, this random error would actually cancel out, and we would more likely converge to a true score for a particular color stimulus pair. Right, that is why in some experiments, in some cognitive experiments, there can be as many as thousands of trials, because in those experiments they assume that the amount of random error can be quite large, right? So reliability refers to the extent to which measurements can be repeatable. It refers to the consistency of measurement, right? So if you are 55 kgs today, you will be 55 kg tomorrow. If you are 1.7 meters today, you will be 1.7 meters tomorrow, right? Obviously, after 1 year or after 10 years or after 20 years, you may not be 55 kg, you may not be 1.7 meters, right? That's another side of the question. But as far as possible, measurements should be consistent and should also be stable over a variety of conditions. So if you weigh yourself in a bathroom, it should be kind of the same if you weigh yourself in the living room, right? It should be this kind of the same if you weigh yourself in your friend's place, right? So the stability of measurement. Now, obviously, this is a height and weight, but the same can be said of measures of self-esteem, right? So if we are measuring this concept called self-esteem, right? So your levels of self-esteem should be the same in if you're in a living room versus when you are in the bedroom, or it should be kind of the same on Monday as it is on Wednesday as it is on Friday. Of course, right, sometimes things happen. You might have experienced certain things, certain unpleasant things, and that will affect your self-esteem. So your self-esteem may be fluctuable, but that aside, right, the core idea of it is the measurement, right? The measurement should be consistent. It should be stable over time, irrespective of what is actually happening in the environment. So in reality, there are three types of reliability that you need to learn for this course, right? You can broadly classify them as internal consistency and temporal stability, and then subdivide them into alpha reliability, or what is known as Cronbach's alpha, what is known as inter-rater reliability, and what is known as test-retest reliability. Now, let me just go through the first one in greater detail, because the first one is something that we will go through in the tutorial as well. When you use multiple items to measure one construct, right, how do you know they all measure the same construct? Now, let's take self-esteem for example again. All right. How many items do you think we need to measure this thing called self-esteem? Why don't we just in psychology, right, often we have multiple items measuring one particular construct. In fields like sociology and fields like political science, I usually don't see that, but in psychology, it's very, very common for us to measure a single construct with multiple items. And the core assumption is this, right? Why do we do such a troublesome thing? Is that we assume that each item that we measure may not completely cover what self-esteem actually is. For example, some of you might want to measure self-esteem with this question, right? I feel that I have a number of good qualities, right? That signals seems to mean that if you feel that you have more number of good qualities, all right, the higher your self-esteem is. But notice that, let's just take this as a Venn diagram, right? Now this is your self-esteem. It's an abstract, right? Remember this is an abstract self-esteem. You can't really see it. You infer that this circle actually exists. And when you have this item, right, you might think that this item overlaps with substantial amount of self-esteem, right? This concept called self-esteem, but a lot of this whole circle, the rest of it, right, is still missing, right? So it accounts for maybe 20% of self-esteem, but it itself is not encompassing the whole self-esteem. At the same time, what is in this blue circle, right, also have aspects that are not related to self-esteem, right? Like this crescent moon here, right? You can see my cursor as it traces, right? So this aspect of this question may actually not be capturing self-esteem, may be capturing some other things, right? Happiness in real life, for example, right? This one could represent happiness, right? So even in this particular question, we have some that falls in self-esteem, some that don't fall in self-esteem, and even for those that falls inside self-esteem, right, it still leaves other aspects of self-esteem unaccounted for. And therefore, we might say that it's not sufficient just to have one item measuring self-esteem. We might actually want to have another item measuring self-esteem, right? On the whole, I'm satisfied with myself. But the same problem also occurs, all right? Some will fall inside self-esteem, some will fall outside self-esteem. Of those that fall inside self-esteem, right, it still leaves a substantial amount of self-esteem that is not explained. By now you should get an idea of what's going to happen next, right? So we come up with more and more items, right? We come up with a third item, right? And the third item will also have the same problem, right? Some will fall in, some will fall out, and it still leaves some areas of self-esteem that's unexplained. Now, this is already a far better improvement over the first question, right? When we first started out, we only have one measure of self-esteem, and you realize that maybe 80% of self-esteem is still unknown. But as soon as we added the second measure, right, this unknown area reduces. And when we added a third measure, this unknown area reduces again. Of course, we can add a fourth one, we can add a fifth one, a sixth one, with a seventh one, and so on and so forth. But you get the idea, right? So the idea of this internal consistency really is this. If I score high on this, will I score high on this? Will I score high on this? If I score high on this, will I score high on this and high on this? If I score high on this, will I score high on this and high on this, right? So how much does, if one measure goes up, will the other measure also go up, right? Think of these three items as balls on a string. If you lift up one ball or one end of the string, right, hopefully the rest of the other two, right, also rises as well, right? So internal consistency has this idea. All the items should consistently measure this thing, this abstract concept, right? They should be somewhat related to one another, right? They should hang together. Okay, so there is a mathematics behind this thing called Cronbach's alpha. I will not talk about Cronbach's alpha too much in this particular class. We will actually reserve that for the tutorial. You don't really need to know this formula at all. But for those of you who are curious about the mathematics behind the formulation, right, this you might want to Google up a little bit more about what the formula actually means. You do want to have a good alpha is somewhere between 0.8 to 0.9. All right. Some people will say 0.7 is acceptable as well. Points below 0.7, it's kind of a bit difficult to accept that as a reliable measure. Now I'm going to ask you this question during the Q&A, right? So do think about this question, all right, and tell me your answers during the Q&A. Right, again, bear in mind that there are two possible answers. Replication and reliability are not the same thing, right? We just had a tutorial last week about talking about replication crisis. Now reliability is something that is reserved, strictly speaking, for measurement issues. Replicability is how likely will my next finding be significant finding if I know that this current finding is already statistically significant, right? If you're using a measurement, a tool, right, of self-esteem, in your first study, right, and if this tool that you use is a good tool, it makes your next study on self-esteem likely to be replicable, right? Because you are using a good tool again, right? So think of measurements as tools, right? And think of reliability as how good a tool actually is, right? So if you can use a good tool always, right, it increases your chances of finding replicable results. But just if your tool is good, right, it doesn't necessarily guarantee that you can replicate your findings, because findings don't replicate for many different reasons, right? For cultural reasons, for temporal reasons, for population differences reasons, and so on and so forth, right? And for statistical reasons, low sample size, problematic participants, right, so on and so forth. Sometimes, and I see this in a very small subset of literature, sometimes authors confusingly will write something as statistically reliable when they actually mean statistically significant, right? So bear this in mind. Every time you see this thing called statistically reliable, um, be very cautious of how the author actually used the word reliable. I don't think that should be actually a term that they should be using. Right? I think they should be using statistically significant. Right? So reliable and significance are again very different thing, and significance and replications are also very different things, and replication and reliability are also different things. Right, so that's all I have to say for reliability. There are actually two more classes of reliability, which is the inter-rater reliability and the test-retest reliability. I think these are sufficiently simple enough that I don't actually need to spend time explaining it. But doesn't mean that they won't come out for exams, right? You should still know what they are, right? By and large, I will also repeat these concepts again in the tutorial. When it comes to validity, you should really pay attention to this picture, right? This picture is a very familiar picture. Each blind man touches a part of the elephant and comes up with his or her own interpretation of what an elephant actually is. Right. So in terms of measurement validity, we also face the same problem. The general question that we are asking is, are the measurements really measuring what the construct is actually measuring? All right. So in terms of reliability, that's actually fairly easy to understand and fairly easy to get the statistics out of it. But validity, it's actually a very how to say, superfluous, very vague concept. Actually, technically, it's not a vague concept, right? But it's just a class of many different very similar terms. And I'll explain to you why it's tricky, why some of these definitions are very tricky. But first, we need to realize that if you don't have reliable instruments, right, then nothing else can be valid. If an instrument is not reliable in the first place, then you don't need to talk about validity. Validity simply cannot exist without reliability. Right, the history of science has lots of examples. For example, um, phrenology, very commonly covered in Introduction to Psychology. Lie detector, fingerprint analysis, right? Basically, the idea behind all three is, or each of these three is that phrenology assumes that certain bulging up of your skull is supposed to signify, for example, morality, intelligence, and so on and so forth. In 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 this lie detection paradigm, right? Arousal. If you are aroused when someone is asking you a question, that means you are, lying. Fingerprint analysis, you can check it out, right? So, does arousal necessarily mean that one is lying? If you have a bulge on your skull, right, at the prefrontal cortex, for example, right, does that necessarily mean that you're smart? Right? Obviously, now we know that the answer is no. But back in those days, people thought that the answer was yes, right? So science is in some sense filled with mismeasurements. Now, internal validity, you have to commit this by heart. These are only examples, but you have to commit the idea of internal validity by heart. Now, internal validity, in some sense, is how you can make sense, how your conclusion is actually defensible. For example, right, let's say you are a manager of a company and you test your employees on leadership satisfaction, and only 50% of them responded to your survey, and all say they like their boss, right? They like you. Now, are you going to take that as face value and say that, I'm very well liked by my employees, right? Knowing that only 50% of the people who responded, right? Obviously, many of you would sense that something is quite wrong. A job satisfaction survey, right? Let's say you want to you want to know how satisfied people are with their jobs, and you do it just a week before Christmas, or just before a week where just after they received a nice bonus. most people would feel happy about receiving bonus, right? So you might actually get an misestimation on what the level of job satisfaction actually is, right? So there's neither of these in neither of these scenarios there is actually good internal validity to infer that the results are actually accurate, right? So you will practice more about internal validity issues over the next few weeks, and we'll see how that goes. There are also other types of validity issues that one should consider. Construct validity is something that we will practice actually during the tutorial, which is how much is an actual measure of a construct, whether the construct is really measuring what it is supposed to be measuring, right? So that's construct validity. Predictive validity is something that you have to remember and have to understand. For example, a typical scenario is, how well does the SAT score predict the GPA? I think SAT is not very relevant in a Singapore context, but you get what I mean. Convergent validity, right? Let's say you have this measurement of politeness. You want to measure this thing called politeness, and you have these two things that you observe, or these two things that you observe, right, in order to know whether someone is polite or not, right? The number of swear words that this person uses every 24 hours, and the number of times this person has showed the middle finger in the last 24 hours or 24 days, doesn't really matter, right? Now, if these two measurements are good measures, reasonable measures of politeness, naturally these two measurements should correlate with one another, right? So that's very, very logical. So if these two do correlate, then there is some kind of convergent validity. Discriminant validity is something very, very tricky. I think you should just read the definition here, and we'll leave the formal exploration during the tutorial. External validity, right? How generalizable is this relationship across persons, across settings, right? Yeah, I think that's intuitive enough. Now, how do you know if a measurement is valid? All right, you can use statistical methods to show predictive, convergent, and discriminant validity. In the tutorial, we will explore the first and the third, but basically, and I will share with you, right, the methods are very, very similar, right? It's nothing more than a t-test, usually nothing more than a t-test or a correlational test. You can, of course, also argue using logical arguments to say that, hey, something has internal validity, something has good internal validity or poor internal validity. And very often when it comes to issues of construct validity, right, we also have to rely on logical arguments. For example, is hair length a good measurement of intelligence? Right? Obviously, many of you would say, no, of course it's not. Right? What are you relying on when you say it's not? Right? Usually you will rely on logical arguments, right? Because most of us cannot possibly imagine what has hair length got to do with intelligence. Right? By that, you are making use of a logical argument. External validity is often also shown using logical arguments, right? For example, if we want to sample JCU students' attitudes towards environmentalism, and we want to, someone claims that, okay, JCU students is representative of students in general, right? But another person might disagree with that, right? Usually, what happens is each relies on some kind of logical argument rather than some kind of statistical method, right? So in terms of validity, right, there are statistical methods and there are logical arguments that you can use to prove either one. Sometimes you can use both for each one, but sometimes it's not possible and also not necessary. Okay, let's look at one test. This is a task of risk taking, and I will explain to you the principles of this test. Now, This is known as the balloon analog risk task. The basic idea is this: people sit in front of a computer, there are 10 balloons, right, and they pump the balloon, right? As you know, with all balloons, the more you pump, the greater risk that the balloon will pop. But in this particular task, right, every pump people make, right, it earns them 5 cents. And at some point in time, they have to decide to cash in. Now, the question I'm going to ask you is this a valid measure of risk taking? In other words, does this task have construct validity? Right? You pump, right? At some point in time, you can decide to cash out and then keep the earning, or you can keep pumping until you decide a place to stop at. Of course, with every additional pump, you risk losing your money, right? So there's some element of risk taking that you can sense, because what exactly is risk taking, right? Risk taking is, you putting in some effort and doing something in hopes that you will get a desired outcome. At the same time, that there's a probability of losing something. If there's no probability of losing something, then something cannot by definition be called risky. The question is, does this task use this principle well in this balloon explosion task? Let me give you another example. In some countries, still in this modern day, and certainly in the past, there's some idea that fingerprints, one's fingerprints determine one's personality, right? So if you have a particular fingerprint that is like that, circular, 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 right? Are you then a confused person, right? If you have a very linear kind of fingerprints, most of us don't, right? Are you then a straight thinker, right? So there's a lot of this kind of ideas of how fingerprints can actually predict personality. I think there was one researcher, probably a pseudoscientist, who claimed that the more complex fingerprints are, right, the more complex the brain wiring actually is, and therefore some of us would know that or would think that the more complex your wiring in your synapses are in your brain, right, the greater the intelligence is. I'm not explaining this well in part because the theory itself is just bogus. All right, I there is no good reason to think why fingerprints should actually predict intelligence, irrespective of what might be seemingly logical to you, right? You can check out, just Google this validity of the glyphics, right? And you can read a lot of comments about it. Now, the issue here when it comes to measurement is this, right? Are fingerprints a valid measure of intelligence, right? Most of us would object to it, right? But read more about it. Beyond psychology, psychometrics is also very useful, right? It's very useful to think of certain things in the world from a psychometric lens. Let me give you two examples. Now, if you're from my 1106 class, you might find this example very, very familiar. I have been telling my classes that I used to make trips to America at least twice a year. And very often in America, what happens is, if you go to Walmart, if you go to any supermarkets, pharmacy, whatever, right? Very often people will say, "Oh, how are you doing?" Right? And when I first went there, I thought they were actually being very polite, right? Because coming from Singapore, no one actually asks you how you're doing when you buy food from them, right? You go to NTUC, you have not experienced someone asking you how are you doing, right? That would be freaky to us in Singapore. So when I went over to the US, and practically everyone was always asking me how I was doing, I was genuinely pleased. I thought I was being very flattered, and I thought they were being polite. So herein lies the problem, right? We have this idea of politeness, we measure it with, whether people ask how are you doing, and we by them asking how we are doing, right, we infer that they are being polite. That's my inference, at least for the first time when I went to the US. And then subsequently, I realized that, when people ask how you are doing in the US, they don't really care about your answer, right? Whether you answer good or bad really doesn't matter to them. So I thought, then I switched my idea or understanding of this question to, instead of being measuring politeness, I switched my understanding to it being a measurement of rudeness, right? Because in my culture, in Singaporean culture, right, it's very strange to ask someone about, how their day was without actually being interested in their day, right? So what initially I thought was a polite gesture, now I see it as somewhat a rude gesture. Of course, you might disagree with me. That's besides the point. But the point here is, certain things in social life, you can analyze it using a psychometrics lens, right? In this case, it's about construct validity, right? Is this the best measurement that one can have about politeness, or is this the best measurement that one can have about rudeness? A couple of days ago, my friend posted this on his Facebook. I think he is a counting agent for one of the wards. I don't actually know which one. But take a look at what he said. Now, I want you to learn how to identify the psychometric assumption in this Facebook post. It's not very obvious if you're doing it for the first time, right? But with more practice, you can actually find a lot of assumptions, psychometric assumptions in social discourse. Fundamentally, what he's saying is this: you can draw it out in a diagram, right? He's saying that if you vote for one particular party, then it means that you are wishing for a balanced parliament, because that's exactly what he said. Then you're wishing for a fairer and kinder system, and then you're wishing for a diversity of views. And if he is correct, then these three subfacets, right, would actually be correlated, right? If you score high on a desire for a balanced parliament, you would naturally also score high for a fairer and kinder system, which you would naturally also score high for diversity of views, right? That's, if you can actually measure these three constructs, right, these three could be correlated. Now, is that true? I honestly don't know, right? But my core question is, would there be other reasons that people would vote for one party versus the other that has nothing to do with all three or any of the three, right? So sin in this way, your knowledge of psychometrics can also inform you of broader societal issues that are developing, that are happening. Okay, so I've come to the end of this class. My take-home message is this, right? Reliability and validity are very key central concepts in psychological research, right? This is irrespective of whether you are, in neuroscience, or whether you are in social psychology, whether you're in developmental psychology, or whether you are in cognitive psychology, right? They are very, very fundamental issues in psychological research. We will certainly practice many of these issues again when it comes to the tutorial. Validity issues permeate a lot of daily life too, right? For example, many of this, domestic quarrels stem fundamentally from validity issues. For example, right? Let's say a husband doesn't say "I love you" to his wife, and then a wife thinks that the husband is unromantic. Think about this, right? Romanticness, right, is also an abstract concept, but saying "I love you" is a concrete concept. Now, does saying I love you frequently or not, right, is that a good measure for romanticness, right? Some of you would agree, some of you would disagree. Regardless of whether you agree or not, right, you know where I'm going for, right? What I'm going for, which is a lot of issues in daily life can be examined with a psychometrical lens. Now let me end off with this little cute and funny photo that I found on the internet. All right, you notice that in this particular photo, Obama seems to be looking at a female, uh, the butt of another female. Right, so is staring at other people's butts a good measure of lust? Right, think about this issue. Right, obviously it's not really a serious question, but the fundamental principles is this. Right, how do we know that we are measuring something accurately and reliably? Right, so I will end off with that note, and I will see you all in the Q&A class.